Hello my dear PU champions, welcome back to our channel Diksha Karnataka. Why I'm here today? Today I'm here to deliver a lecture that you all have been asking for. When I prepared the similar content, similar lecture for your PU1 syllabus, you all said, sir, it is unfair that you gave for PU1 but did not give the support lecture for the preparation or for the revision of chapter syllabus coming for our FA2 PU2 maths. So I'm here to deliver just that. So this will be a very useful video where I'm going to cover 4 chapters. The chapters will be integrals, application of integrals, you'll have differential equations and 3D geometry. Okay, so stay till the end of the session, learn all the questions that I've brought for all of you. These are the most important ones. If you consider the entire syllabus, you don't have time to revise everything. So I have filtered out the problems for you. You can go through them, you can practice these ones at least first and then later move on to the other problems. So these are the must do questions from all these 4 chapters for the syllabus of your FA2 PU2 maths. Is it clear now? Can we start the session? Yes, let's start. So what do we have first? First thing is, as I said, the chapter is integrals. Why I've taken it first? Because there'll be a lot of questions from here. This is high weightage in your PU2 as well as in this FA2 as well. And the questions are a little tricky in this. Most of you find this chapter difficult. That's why I've dealt this first, and in this as well I've taken more number of questions because this has a vast syllabus in it. So whether it is particular functions, by parts, partial fractions, substitution method, everything is discussed alongside with your properties of different integral. So questions on all these categories I have taken and will solve them in detail, and of course MCQs as well. But I hope you know that MCQs from this chapter is less likely to come in your PU2 finals, but since it is a FA2, they can give you MCQs from here as well. Okay, so because there's no syllabus, there's no blueprint given for a FA2, is it? No. So for FA2 the questions can come from here in the MCQ category, but in your PU2 final examination, chances of questions from integrals is very less likely. Okay, so alright sir, let's start our preparation of FA2 PU2 maths. Now, for someone who is, of course, you're writing PU2 FA2 means you are writing your PU2 boards, and if you are not completely prepared with your syllabus, you're just starting right now and still want to score a good marks in PU2, for that we have brought for all of you target 90 plus PU2 crash course. Okay, in this crash course we're going to cover up your one-shot lectures. PCMB will be covered, the subject cover will be your physics, chemistry, maths, biology alongside Kannada and computer science. We'll have live and recorded classes, means you'll have live doubt clarifications alongside with recorded lectures. Formula sheets will be given. You'll have dedicated WhatsApp channel. You have live, as I said, live doubt solving, lecture notes and PDF, complete P by Q lectures and PU2 dedicated test series. This was something that students loved it last year, so we have brought it back, an improved version which will help you get a very good score in your boards examination, because you all know that your KSET score, your KSET rank depends upon PU2 score. That's why it is becoming very important for us to get a very decent, very high score in our PCMB in PU2 boards. Okay, and all of this is bought at a price of only 999. Okay, so this is a very something that we can all afford. Understand, for PU2 boards we had to make the price in such a way that everybody can benefit from here. Okay, so are you clear with this FA2 I'm doing right now? But for you who wants to prepare a full syllabus revision and coverage, you can simply enroll into the PU2 target 90 plus crash course. So the link will be given in the description of this video. Let's continue. Now it's time to solve the questions on MCQs of integration. First one, sin x upon 1 plus cos x. This is a very simple question. All of you can see and solve it, because if I have 1 plus cos x over here, sir, I can take 1 plus cos x as t, and my derivative is what? Minus sin x dx as dt. This whole thing becomes integration of minus dt upon, what is it? T square, right? Upon t square. Answer will be what over here? Please check. It will become minus 1 by t plus c. So plus 1 by t plus c. So what is t value? 1 plus cos. So option C is the right choice. Option C is the right choice. The first question, which is the question number 71 of your integration. I've taken this one from question bank. So I've done my homework. I went through all the questions in your question bank in your NCERT, and I picked those because these make sense to me, and trust me, this will make sense and help you a lot in the preparation. Okay, my filter has been done on these questions, which will help you achieve that 30 plus score that you are looking for in your FA2. Next question. Okay, this is a standard integral tan inverse. What is the formula for this? I hope all of you remember. 1 by a tan inverse of x by a. So x by a becomes 4. I can write directly here also 4, na? Yeah. Check here. A square is 4 square, right? So I'll have 4 here. Now in this I can substitute the limit. I'll keep the 1 by 4 constant outside and substitute back the limit as 4 and 0. When you put tan inverse of 4 by 4, it becomes tan inverse of 1 minus lower limit if you put, it will become tan inverse of 0. Now I hope you know this answer. 1 by 4 into, this will be pi by 4. Answer is pi by 16. So option D is correct. Right, tan inverse of 0 is 0. This will be pi by 4. Answer is pi by 16, sir. Okay. Next two questions. Okay, so variety you can see over here. Again, we're going to use our substitution method in this particular question. We have x square plus 1 as t. So 2x dx is dt. So I get x dx as dt by 2. Okay, dt by 2. And I can change the limit also, right? Yeah. When x was 2, sir, when x was 2, please check. Or should we get it in, okay, let me do one thing. Forget about the limit change. We can simply integrate and get the result in this form. Okay. This whole thing will become what? Forget about the limit change. Integration of x dx is dt by 2, so 1 by 2 is outside. Dt here. Okay, this will become t. What is the integration of this? 1 by 2 ln t, right? So this becomes basically 1 by 2 ln of x square plus 1. Now we can apply the limit, bacha. Right? Either you can change the limit and get the answer later, or you can simply switch back the variable to the original variable and use the same limit. Your choice. Whichever works the best for you. Put the limits over here. 2 to 3. 2 to 3, sir. Yes. So we have 1 by 2, right? This. And ln. If I put 3, then I'll get what? 3 square plus 1. That is 9 plus 1. So 10. And minus ln. This is upper limit, right? Lower limit will be 2 square plus 1. That is going to be 5, right? So ln 5. Log a minus log b is what, sir? No surprises there. A by b. Answer is 1 by 2 ln 2. 1 by 2 ln 2 is option B here. Option B here, please check. Yeah. Next question can be solved. This simple one. Yeah, this is direct answer, right? This is the form ex f of x plus f dash of x. The derivative is given. The answer is given by what? The answer is given by ex f of x plus c if it is a indefinite integral. So answer becomes, check here, this is your fx, 1 by x derivative is minus 1 by x square. So answer is option C. Answer is option C. Fair enough. Let's move on. Next question. Now this one, this is a PYQ as well. I hope you know that. This is a PYQ as well. So how do you solve this question? Simply take x ex as t, differentiate this, you'll get x, let's say I keep as it is, you'll get ex derivative as ex plus, this time x derivative is 1, ex as it is. Over here we'll have dx by dt, we'll get this as dx equals to dt, let's say. I'm getting over here e power x common, x plus 1 is left, with dx is dt, right? I've differentiated like this, dx by dt, because I differentiated everything with respect to the variable t. Okay, no problem. Next, substitute back. We'll have integration as e power x. Okay, this whole thing is dt, and we have sine square of t, which is integration of plus cosec square t dt. You know the answer, minus cot t plus c, minus cot of t plus c, so minus cot of x ex plus c. Answer is option D. Right? Makes sense? Not clearly visible. Can I change it? Yes, sir. Let's change it. Minus cot t plus c. All right, so next question, again sec x into sec x tan x is there. We can, sorry, sec square is there, right? So sec square x plus we have secant x and tan x. Integration of this is going to be tan and this is going to be sec. Answer is tan plus sec, option B. Yes, question like this easy can also come. Question this easy can also come. Okay, yeah. Next problem. 3 cos x plus 4 upon sine square x derivative, sorry, integral, my bad habit. So I can see here they are getting two terms everywhere, right? The constant is there, that is the third term, but regardless we have two terms of variables. So we can separate them. So we'll have over here, what bacha, please check. 3 cos by sine will be 3 cot x, am I right? One of the cos with sine will become cot. We still have one more sine over here, that will become cosec x, plus is there 4 by sine square is 4 cosec square x. Agreed? What have I done? I have simply taken two parts, one with 3 cos x by sine square, that becomes 3 cot x cosec x. Second is 4 by sine square, that becomes 4 cosec square x. Integration of this, I hope you know this. If not, don't worry, I'll tell you. This integration is going to be what? Minus 3 cosec x, same fashion as sec. Okay, derivative of sec is what? Secant x into tan x. So derivative of cosec x is what? Minus cosec x into cot x. I'm looking for integration here. So derivative of, sorry, integration of cot x into cosec x will become minus cot x. Okay, what did I say? I said that derivative of cosec x is minus cosec x into cot x. So if you integrate this, you'll get this part. Since there was no minus sign over here, you'll get minus in this term, and same fashion over here, minus 4 cosec square will become what? Cot x plus c. So minus 3 cosec x minus 4 cot x. I think we have the answer, no doubt about it. Simple question. Again, this question is same as this one, just that we had to do one step of simplification. That's it. Okay, again a formula based question, and this is a very familiar formula. This we see at some occasions. That's why some of you might find it difficult, because we have seen this formula at multiple occasions. Sec square integration is tan sir, and sec tan x integration is sec x sir. So we have seen that at multiple occasions, but this comes less, that less often. Hence that's why this is little bit different, or we have seen it less number of times. X cos x, a question on by parts. Eyelet we all know. Let's apply eyelet. Preference given to the algebra is x. So x as it is, integrate cos x, comes a minus sign, differentiate x, you'll have 1, differentiate x, you'll have 1, and integrate cos, you'll have sin x, one more time integration, so dx. This is x sin x, bicha. This will become, integration of sin will be minus cos, there's a minus sign, so plus cos x plus c. X sin x plus cos x plus c. Option D. X sin x plus cos x plus c. Moving on. Now, so we have reached the end of our MCQ section of your chapter integrals. Okay, now it's time to solve some subjective questions, whether it is 2 marker, 3 marker, and so on. This particular question is a 2 marker. This is a 2 marker. Okay, how to solve it? Simply take sir x square as t. Actually 70% of the question, more than 70% actually, can be easily solved if you know substitution method correctly. Okay, means if you're very much comfortable, if you're very much good at the method of substitution in integration, you can solve a lot of questions by using this technique. But if you are not, then you need to know everything. Okay, for example, in this question also very simple problem, differentiate 2x. Okay, so far so good. Limit change, we can do that. When x is 0, t will be 0 because we have a square of 0. When x is 1, t will also be 1 because the square of 1. So limit is defined now. This is my lower limit and this is my upper limit. Since it was easy to find the limits over here, I just chose to do that. Otherwise, I would have simplified it in the terms of original variable and used the same limit. Okay, chaliye. So this becomes what, bacha? This becomes x dx will become dt by 2 is a constant outside. Okay, and this is nothing but e power t, right? So 1 by 2, and limit is 0 to 1, sorry. So e power t is simply e power t and 0 to 1. I hope you know the answer. 1 by 2 as it is. E power 1 is e minus e power 0. My answer is 1 by 2 times of e minus 1. Y power 0 is 1, no? So 1 by 2 times of e minus 1. 2 marker. Moving on. Cos 6x root of 1 plus sin 6x. Is it a difficult question? Of course not. Substitution, as I said, differentiate, you'll get cos 6x. Is it over? No. You have to differentiate this to the chain rule. You'll get what? 6 one more time. You'll have dx, you'll have dt. So you get cos 6x dx equals to dt by 6. Combine these two, bacha. Combine these two. You'll have 1 by 6 outside, dt over here, and you'll have this as root of t. Root of t. Integrate this. So t power 3 by 2 by 3 by 2. Okay, I hope you can see that. 2 and 2 is cancelled. 2 and 6 is cancelled with 3. My answer is simply over here 1 by 9. T is what, bacha? T is 1 plus sine. So 1 plus sine 6x power 3 by 2 plus c. Another 2 mark question. Another 2 mark problem. Okay, moving on. Find this. What is this question? Same form, again 2 marks. We have e power x over here, expand it. Sec x will be as it is sec x. Over here we'll have sec x and tan x dx. I hope you can remember this form. This is your f of x, and this right here is your f dash of x. Answer is given by, what's the answer given by? 1 second. Answer is given by e power x f of x plus c, which implies e power x secant x plus c, and here's your 2 mark. Here is your 2 mark. Okay, moving on. This is clear, right? No problem over here. Not a problem. Now this is your 3 mark question. Okay, this is a little, it's easy only, but little bit a 3 mark problem. Check here. If I take again x plus log of x as t, differentiate this, you'll get 1. You'll get 1 by x dx as dt. You get x plus 1 upon. Okay, I don't think this is a 3 mark. This is a 2 marker only. This also is a 2 mark only. Okay. Dx is dt. We have x plus 1 by x dx. That becomes what, dear? This becomes t square. This is t, right? So t square, this whole thing is dt. Yeah, this is 2 marker only. What is my answer? T cube by 3 plus c. What is t cube? X plus log of x the power 3 plus c. This right here is my final answer. Divide by 3 actually. Divide by 3. Please check. Decent. No problem. No worries. So what I've done, I'm trying to make a point here. What I'm trying to make a point of, that this chapter can also be very easy. Okay, if you know the concept well, if you have the right mix of problems that you have solved, what happens, as a student, we tend to solve only one type of question. Let's say I am trying to solve to the integration, I'll practice only on substitution, I'll practice only on a particular function or like that. Don't do that. Try to keep mix of all the questions, then you will see 1 marker, 2 marker, 3 marker like that. Then you'll see a real progress in your preparation, and then only you'll get the confidence from this chapter. Okay, let's continue. See, what is this? A partial fraction. This is a PYQ as well, and usually they ask us partial fractions of only two factors or a quadratic form, but they can ask you cubic also. They are also of the same form, but most of the times they stick to this one. That's why I keep putting it back in your preparation every time. But do practice some more questions of the cubic form in the cubic form in polynomial in the denominator form. This is a quadratic one. 1 second. We'll have two unknowns. Okay, we'll just figure out the numerator. B times of x plus 1. Here we have only x. Let's not compare the denominator anymore, because we all know that denominator is actually same. Okay, now we'll put x as minus 2. Check, this will become 0. So you'll have minus 2 equals to a into 0 plus b into minus 1. Minus 2 plus 1 is minus 1. So you get minus 2 equals to minus b. This comes value of b as plus 1. Sorry, plus 2. Value of b as plus 2. Okay, I can do it without any overwriting. Yes, much better. Okay, now this time substitute x as what is it? Minus 1. So you'll have over here minus 1 equals to a times of 1, and this is going to be again b times of 0. So this gives me the value of a as simply minus 1. The value of a is simply minus 1. I can use that back in the integration now. So I can instead of using this, I can use integration of the split part. It'll be easier, right? So let me use the right hand side for this. We have the values of a and b now. So by integration, I will simply be integration of minus 1 upon x plus 1, of course with dx, plus 2 upon x plus 2, of course with dx. I put the value of a and b back in the integration. Okay, so my integration will be continuing like this: minus log of x plus 1 plus 2 times of log of x plus 2 plus c. Okay, and I have to continue one more time. Minus ln x plus 1 ln of x plus 2 the whole square plus c. This minus this will make what? X plus 2 the whole square divided by x plus 1 plus c. This is your integration I. This right here is your integration I. X plus 2 the whole square upon x plus 1. Is it making sense to all of you? A simple question on particular functions. Next. Now, this previous one was partial fraction. This one is particular function. We think like that. Remember, we'll start doing like this, sir. This 4x plus 1 will be derivative of a into derivative of this quadratic plus b. We have this forms in NCERT. We'll solve it like this. I agree with that. Do try that method. Always try that method. Think of that method automatically if you see that form of root of quadratic upon when you have numerator as a linear function. Listen to me. If you have linear by root of quadratic, try that method. Okay, right? The numerator as 4x plus 1 is derivative of a times of d upon dx by this plus b. Okay, but don't forget to check the second way as well. This will work in most of the questions, but this is a unique problem and much easier question. You'll see. Basically, if you take 2x square plus x minus 3 as t, differentiate, you'll get 4x plus 1 equals to, plus 1 dx plus 1 dx equals to dt. Now you can see here, this is same as in the numerator. So actually this question becomes what? dt upon root t. dt upon root t. So basically I said that usually this kind of question is solved using what? Particular function. You have to make this in that form, get the value of a and b. From there you after getting the value of a and b, you change it to the perfect square method and then integrate. You'll get two terms, get the answer. A lengthy question, right? But in this problem actually what they have done is the numerator is the derivative of the function given in the given inside the root of denominator. Okay, so this is very simple, right? T power minus 1 by 2 is there, so I'll get here t power 1 by 2 by 1 by 2 plus c. Yeah, so root of t into 2 plus c. So 2 times of root of t is what? 2x square plus x minus 3 plus c. An easy, very easy problem on your screen. Next, x sine inverse of x upon root of 1 minus x square dx. Now how would you solve this particular problem? Same technique. Take sine inverse of x as t. So what are you going to get? You'll get x as sine t. Okay. Differentiate this. You'll get 1 upon root of 1 minus x square dx equals to dt. This part is here. Please check. Dx upon root of 1 minus x square is there. So we get integration of x is what? Sine t. Sine inverse is what? Just t. And this is dt. Now what is this question? This is a question of combination of by parts as well as your substitution method. Okay. So we have again same form islet. We have islet. So algebra has a preference over the trigonometry. So this is nothing but your t. I'll keep the t as it is. Integrate sine t with dt. There comes a minus sign. Derivative of t is 1. You'll have minus cos t dt. Integration of sine is minus cos. Right? Now continue on this side. We'll have this answer as minus t cos t, and you'll have here plus integration of cos t dt. Have a look. This will become what? Minus t cos t plus sin t plus c. Can we keep this as a final answer? Of course not, because the question was given in the form of the variable x. We have to switch back. Okay. So sin t will become x. What about cos t? So this will be what, dear? Please check. T is what? T is sine inverse. Sorry. T is sine inverse. So right here, sine inverse of x for t. Okay. And cos t will be what? Cos t will be root of 1 minus sine square. Cos t will be root of 1 minus x square, because sin t is x. So root of 1 minus x square. So write that over here. 1 minus x square plus sin t will be what, dear? Sin t will be x plus c. I can write it in this form: x minus root of 1 minus x square sine inverse of x plus c. This is your final answer, a 3-marker. This is a 3-mark question. Got it? Done? Have a look. Next. Okay, another 3-mark question. So we have e power 5 log x, e power 4 log x, e power 3 log x, and e power 2 log x. Whenever you have log, try to take the coefficient as their powers. You'll have a much easier life solving the problem. E power log x power 5 minus e power log x power 4 by e power log x power 3 minus e power log x the square. We have dx and integration. E and log are the inverse function of each other. So basically I'll have only x power 5 left. So x power 5 minus x power 4, x power 3 minus x square, integration. So you can see I have x power 4 common here, numerator. I'll have x minus 1 left in this, and x power 2 in the denominator. I'll have x minus 1 again left in this. Integration continues, this and this is cancelled. So now I have what? X power 4 by x square dx. This is cancelled. I have x square. Integration of x square dx is what? X cube by 3 plus c. X cube by 3 plus c. I did not say, I said it is a 3-marker. I did not say it is a difficult 3-marker. This is a 3-mark question, but it is a easy one, not a very difficult one. And you can see the result is over here. So why I wrote all the steps? Because this is your PU2 boards. Steps carries marks. It's not CET. It's not any competitive examination. So steps, we need to make a habit of solving and writing in. Next. Clear, right? This is clear. No problem. Okay. Now we are moving to the 5-mark question. This is a 5-mark problem. This is a 5-mark question. It has 2 parts in it. We'll solve both the parts one by one. It's a 5-mark question. Okay, please check. Find the integral of 1 upon root of a square minus x square, the particular function, and based upon that solve that question. Alright, start with the part 1. Part 1 is very simple. Integrate 1 upon root of a square minus x square. Of course, there will be a dx. Take x as a sine theta. Since we know that it's going to be helpful, I'll take x by a as sine theta. X by a, excuse me. Yeah. Sine theta. Okay. So this gives me what? Theta is sine inverse of x by a. All right. So now differentiate this. You'll have dx as a cos theta d theta. Use them together in this integration. We'll have integration of a cos theta d theta divided by root of a square minus what is x square? A square sine square theta d theta. Correct? We can take a square common. So we'll have a cos theta over here. I wrote theta 2 times. No, I wrote d theta 2 times. Excuse me. Yes. So we'll have this as it is. I can take a square common outside. It will become simply a. It will become simply a. Sir, I'm taking common and out of the root. It will be a as it is. And we'll have in the root as 1 minus cos square. Sorry, 1 minus sine square. Okay, check carefully. This and this is same. 1 minus sine square is nothing but cos square. In the root will become simply cos. Cos and cos is cancelled. So is a and a. My integration is what? My integration is root of d theta. How much is that going to be? Theta. And what is the answer going to be? Simply sine inverse of x by a. How come, sir? We solved it over here. Please check. We kept the value of theta already ready for us to use. Sine inverse of x by a is my final answer for the first part. Just for the first part. Next part is what? Dx upon 2x minus x square. Okay. Super. We have to make a perfect square over here. Let's try doing that. Let's take minus sign common first. When I do that, I'll get x square minus 2x, because we have to keep x square. Then only you can use the perfect square method. No? Yeah. We have to keep this as positive. Okay, sir. Now check what we can do to make this whole square. I can add plus 1 and remove minus 1 from here. I can add plus 1 and remove minus 1 from here. Check. So add here plus 1 and remove minus 1. This will become a perfect square. Now the first three terms. So this will be what? Dx. Keep the root. Minus sign you start from here. It will become x minus 1 the whole square. No? So x minus 1 the whole square. Please check. X square minus 2x plus 1 will become x minus 1 the whole square, and this minus 1 with this outside minus will become plus 1. Correct? No? This minus 1 right here with this minus sign will become plus 1. Now you can compare this with the original form of the equation, and your answer is, excuse me, and your answer is sine inverse of x. What is this? X is x minus 1, so x minus 1 by a. What is a in this case? 1. Plus c. What is my answer? Sine inverse of x minus 1 plus c. Check. 5 mark question dealt with a simple approach. Yes? Okay, sir. Now we are very close to completing our integration chapter, so just be a little patient. This is a high weightage, so it will take time, but we have to solve every question, and in a way that we don't have to come back to this chapter again and again. Okay, so we have to put our energy when we are doing it for the first time and do it properly. Next, another question. This is going to be a 6 mark problem. This is going to be a 6 marks question. This comes very often in your boards as well as in your FA2. It can also come. FA2 6 mark won't come, but yeah, this is an important question, so that's what I've discussed over here. Proving this particular property of definite integral and this question on it. King's rule, right? Yeah. So in this integration, you're gonna assume this from here. Integration from 0 to a. F of x dx is there. I've taken the LHS part. Replace x by a minus t. Replace x by a minus t. When you do that, derivative will be what? Dx will become minus dt. First thing is this. Limit change you check. When x is 0, your t will be what? Your t will be, check here. This is 0 means t will be a. When x is a, t will be 0. When you put a over here, a and a cancels, t becomes equal to 0. So integration changes now. From 0 to a becomes a to 0. this is a, right? A to 0. This is my lower limit. I hope you can understand that. This is my lower limit and this is my upper limit. Clear? So we have a to 0 and over here x is replaced like this, a minus t, and dx replaced by minus dt. Continue on this side. I can take this minus sign outside, no? It will become minus a to 0 f of a minus t dt. We know that we can use the negative sign to change the limit of the integration. Just do that. You'll have this as 0 to a f of a minus t dt. We also know that we can change the variable of integration without changing anything. Okay, so it will become simply f of a minus x dx. This is same as your RHS. This was your LHS. Please check. So it is your proven statement. Started from 0 to a f of x dx. We are getting here 0 to a f of a minus x dx equals to RHS. This property is proved. The property is proved. Now we're going to move on to do what? The question, the second part of this problem. Okay, sir. So if you apply the same concept, what you're going to do? Replace this function x. Replace this variable, sorry, not function, x by the sum of the limits pi by 2 plus 0 minus x. So you get x value equals to pi by 2 minus x. Replace it, please. So you'll end up with, if I take this as my integration I first, if this as take this equals to integration I, and this is my equation number 1. I've taken over here only. Again, I'm going to write I one more time. Limit will remain same. Check. Root of sine of pi by 2 minus x. I'm replacing x by pi by 2 minus x. Replacing x by pi by 2 minus x. Sine of pi by 2 minus x will become cos of x. So root of cos of x. Same fashion. This will become cos, this will become sine, because sine and cos are complementary function. So sine pi by 2 minus x will be cos and cos pi by 2 minus x will be sine. This will be what? Root cos x plus root sine x dx. Now this is my equation number 2. Check carefully, in the equation 1 and 2, the denominator is same for the function. Root cos x plus sine x, root cos x plus sine x. So I can add them. Add equation 1 and 2. You'll have I plus I as twice of I. This I and this I will become twice of I. And if you add these under the same limits, 0 to pi by 2, you'll have, check here, root cos x plus root sine x. Here we have root cos x, there we have root sine x. Add them and you'll have root cos x plus root sine x. Same thing in the denominator also. In the denominator also. This whole thing is cancelled, bacha. We are left with dx from where to where integration? 0 to pi by 2. We all know this answer going to be what? X. Integration of dx is x from where to where? 0 to pi by 2. So your answer becomes 2i equals to pi by 2, which implies I equals to pi by 4. And we were looking for the value of the integration I only, right? I assume this to be integration I, and we are getting the I value as pi by 4. You can check over here. A 6-mark question is dealt with right now. Okay? Any problem in this one? How will you let you know? In the comment section. Alright, sir. So I think now we are about to close the chapter integration. Yes. So your integral chapter is over. Now we're going to move on to AOI, application of integrals. Same approach. So actually in this one there's no MCQs. No MCQs. This chapter doesn't have any MCQs because in your board's right question comes on the finding the area bounded by ellipse, parabola, straight line, those kind of question comes. So we'll solve those only. No MCQs in this chapter. Find the area of region bounded by the ellipse. Ellipse, okay. We all know the figure of the ellipse. In this case, major axis is x-axis. This will be what? 4. 0 minus 4. Correct, now? What is the major axis over here? X square value is what? Sorry, a square value is what? 16. And a value is 4, b value is 3. So a is more than b. It means major axis is your x-axis. That's what written there, minus 404. How do we know this, sir? PU1, conic section. Yes. Okay. So try to remember from there. All right. So minus 404 we have. Now we also know that all these parts are identical in nature. All these 4 parts are identical in nature. To find the area of ellipse, I can just find the one of the parts area. I can find the area of just one part and multiply it with 4. So my required area will actually be 4 times of area of part 1. 4 times of area of part 1. Agreed, sir. Now how do you find area of part 1, sir? Area of part 1, how can we find is, basically check here, integrate this function, this curve function. What is this function going to be? Some y we can integrate in terms of x, y equal to fx I can write, y equal to some function I can write in terms of x, fx. So write this function integration fx dx from where to where? From 0 to 4. How would you find the area of part 1? You will find after integrating the function fx from 0 to 4. What it means? It means I'm trying to find out area under the curve fx. Now the challenge is to find fx, but it is actually not a challenge. You'll see. So we have figured out that we need the fx and then we'll get the result. Clear? Let's find fx now. So from this equation I can write y square by 9 equals to 1 minus x square by 16. It will give me 16 minus x square upon 16. Cross 9 over there, we'll get y square equals to 9 by 16 and we'll have over here 16 minus x square. Correct now? Now take the root to get the value of y equals to fx. We'll have root of 9 as 3. This is 4 root of, what is it? 16 minus x square. 16 minus x square. Okay? Great, sir. This is the answer for the f of x. Now substitute this y in place of fx. Y in place of fx. Alright, sir. We can do that. We can do that, no problem. So we'll have the integration or area of the part 1 as integration from where to where. The constant I can keep it outside, 3 by 4. From 0 to 4, integration of 16 minus x square. I hope you all remember the formula of this particular function, a square minus x square. You don't? I hope you do. 3 by 4 is there, sir. And excuse me, not equal to into. 3 by 4 into will have the same thing, x by 2, the same root repeats, 16 minus x square, and we'll have minus sign. We'll have minus sign, no, plus sign only, no, sine inverse of a square by 2, right? So we'll have 16 by 2 sine inverse of x by a. So x by, excuse me, x by 4. From where to where? 0 to 4. 0 to 4. So we have 3 by 4. Put x as 4 over here, this will be 0. How come, sir? 4 square will be 16. 16 minus 16 is 0, so that is gone. Now put it over here, you'll get 16 by 2 is 8. So you get 8 times of sine inverse of 4 by 4. Sine inverse of 1. 4 by 4 is what? 1. Okay. Next, there comes a plus minus sign for the lower limit. When you put 0, this will become 0. Please check. 0 into anything is 0, and over here also will be 0 only. Sine inverse of 0 by anything will be 0. Okay. I'm getting here 3 by 4 and into 8. Sine inverse of 1 is what? Pi by 2. Check here. 4 into 2 and this is going to be again cancelled. I have the answer as 3 pi. Answer as 3 pi, and this is the area of part 1. I'm looking for the required area of ellipse. So we'll have 4 times of area of part 1. So we get a equals to 4 times of 3 pi. What is the answer? 12 pi square units. 12 pi square units is the answer. If you want to remember a formula, the area of ellipse is given by pi AB actually. If you want to remember a formula, I can give you that. Area of ellipse is given by pi AB. Check here, the value of A is 4 and value of B is 3 over here. So pi into 4 into 3, 12 pi. 12 pi square unit is the answer for area of the region bounded by the ellipse. Done the derivation, done the particular function integration as well. Okay, and given you the shortcut. If it comes in your let's say MCQ, you can use directly the formula pi AB for the area of ellipse. It looks similar to the area of circle, right? If you had same both the axes, they were not major and minor axis, then it will become a circle, then it will become what? Pi A square, right? There will be no B or something like that. It will be the same value. So it will become pi A square or pi B square because A and B will be same in case of circle. This is done. Next, Find the area bounded by the curve y equal to sin x between 0 and 2 pi. A very good question, but very, very easy as well. Starts from here, goes till here. 0, pi, 2 pi. We all know this is area A and this is area minus A. To find the required area, I need to get what? A plus of mod of minus A, which is twice of A. Correct or not? This is the area below x-axis. It means it has to be negative in nature, and area cannot be negative, so we have to take a modulus for that. When I take modulus, it will become plus A plus A is 2A. So basically, just find the area of this region and multiply it with 2, you get the answer. Let's do that. What is the function over here? Sin x. This function is sin x. So integrate sin x from where to where? 0 to pi, and in this integration, multiply this with 2. This is my final answer. So integration of sin is what? Minus cos x from where to where? From 0 to pi, and multiply with 2. Check here. Take minus sign common. You'll have minus 2 outside. Cos pi is minus 1, and minus cos 0 is again 1. Cos pi is minus 1, and minus lower limit cos 0 is also 1. We get minus 2 into, what do we have? This will become what here? Excuse me, 2, right? Minus 2. I get the answer is plus 4. Plus 4 square units. That's my answer. This is 2, this is 2. The whole thing is plus 4 square unit. Have a look. Next. Find the area of the region bounded by the curve this y-axis and line y equal to 3. Symmetric about x-axis. This is the curve. This is the y equal to 3 line. And this is y-axis. It means this is my required area. This right here is my required area. Correct, no? They are saying this curve, this line y equal to 3 and y-axis. Y equal to 3 and y-axis. The required area is over here. This is my required area, A. So you can find A as integration of this function. This function. What's the function over there? Y square by 4. From where to where? From 0 to this point will be y equal to 3. A very simple question. If you try to think over, over here, if you try to think too much about in terms of x, find an intersection, it'll get, you'll waste time and get it. A chance of getting it wrong as well increases. So why not use directly y square by 4 and integrate it over here? You'll get the answer as 1 by 4 outside, and you'll have y cube by 3 from 0 to 4. Check. 1 by 4 into y cube will be what? Excuse me, 0 to 3 is there, no? I wrote here 4. So 0 to 3 is there actually. So I get 3 cube by 3 actually, and this will be minus 0. So 1 by 4, 27 by 3 minus 0, 9. My answer is 9 by 4 square units. 9 by 4 square units. Please check. That's it. Next. Okay, next is your differential equation. So I've done enough that you need to understand and learn in the chapter. I've done parabola question, I've done a straight line problem, I've done as well a question of combination of straight line with parabola, and then I've done your ellipse question and sine function as well. So all the varieties I've taken care of. Next we're going to move on to differential equations. Let's solve the questions now. Simple ones. Order and degree of differential equation given in the first one. Order is going to be 4 and degree is not defined. Order is 4, degree not defined because definition of differential equation says that differential equation, for it to be defined as a degree, what it should happen, it should be only a polynomial equation of derivative. It should be only a polynomial equation of derivatives, either y dash, y double dash, and so on. In this case, you have trigonometric function. It's not a just polynomial equation anymore. It's a trigonometric function, hence the degree is undefined. Okay, next. Find the order and degree of differential equation. Order is again 1, degree is also 1. What is order? Order represents highest power of derivative. Highest derivative actually. That's your order, and degree is what? Degree is index of or power of highest derivative. Power of highest derivative. Getting it? Highest derivative is your order, and index of highest derivative is your degree. So in this case, your highest derivative is 1 and power is also 1. Answer is option C. The answer is option C. Next question. Find the order and degree of the differential equation given over here. So please check. You might think the degree is 4, but no. Check here. D square s upon dt square is there, no? So what is the order over here? The order is 2, sir, and degree is 1, sir, because highest order is second derivative. Highest derivative is second derivative, so order is 2, and degree is what? Index, the power of the highest derivative. What is the power over here? 1. Answer is 2 and 1 in that order. B. If you're confused, why not 2 and 4? Because 4 is the highest power. It's not the degree. Degree means index of the highest derivative. Degree means power of highest derivative, not the highest power. Listen to me. Degree is not the highest power. Degree is the power of highest derivative. So power of highest derivative is 1. Hence option B is correct. Okay, not C. Option B is correct. General solution of the differential equation given like this: y dx minus x dy upon y is 0. How to solve it? Let's check. I can move y on this side. I'll get y dx minus x dy as 0. Switch the sides. I get y dx equals to x dy. I'll get dx upon x, and I get dy upon y. Integrate it. I'll get ln x. I'll get ln y. I can write plus c over here. Okay, so I'll get what? ln y equals to ln x plus, I can write ln c, no? C is a constant. I can write this as ln c also, right? Log c also is a constant only. So I'll get this value, excuse me, I'll get this value as ln y equals to ln cx, right? So I get y equal to cx, right? Because both sides are log and log. Option C is correct. Option C is correct. Next. The number of arbitrary constant in the general solution of a differential equation of fourth order. Fourth order means, what is the fourth order means? Fourth derivative. Fourth order implies fourth derivative. And then you solve differential equation, what happens? You get to integrate it. You have to integrate it how many times? You have to integrate it 1, 2, 3, 4 times. With every integration you will get a constant. So C1, C2, C3 and C4. With every integration you will get a constant of integration. So you get total of 4 arbitrary constant. Hence answer is what, dear? 4. Answer is 4. Basically, if the degree, so if the order is 4, the arbitrary constant will be 4. If the order is 2, arbitrary constant will be 2. If the order is 1, the arbitrary constant will be 1 only. Have a look. Moving on. Next, we're going to solve the questions on the different types of differential equation now. Subjective, we have to move on to the subjective side now. Okay, sir. Move over here and move dx on this side. Excuse me, what is there? dy upon 1 plus y square and 1 plus x square into dx we have. Integrated. We have to solve the given differential equation. What is the question? Solve the given differential equation. Since they have not mentioned any value of x and y, it means they are looking for general solution. There are two types of solutions. One solution is called as particular solution, where will be no value c or unknown value in that. There will be a condition given for you to find the value of c and use it back in the question. That is called as a particular solution. But usually we tend to end our solution at general solution, and that is where this question will take us. Please check. We'll have tan inverse of y, you'll have x plus x cube by 3 plus c, and that's my answer. Tan inverse of y equals to x plus x cube by 3 plus c. That's your answer. If you want, you can take tan on both sides, it will become y equal to tan of x plus x cube by 3 plus tan c. Doesn't matter. This is your answer. Next. Okay, this is a word problem. We'll see. So basically they are looking for us to find what? for us to find our condition of particular function. You'll see. Find the equation of a curve passing through a point. They have given a point. So this is a curve like this. The point is given 0, minus 2 where it passes through. That any point xy on the curve, okay, okay, there's a point xy on the curve, they have given that, and the product of the slope is what? Derivative. So slope product with y coordinate is equal to x coordinate at the point, x coordinate of the point. Okay, this is a differential equation. Let's solve this. So we have what here? We have y dy equals to x dx. Integrate on both sides. We'll have here y square by 2. We'll have here x square by 2 plus c. So we are looking to find this value c only with the help of the unknown given to us, sorry, the point given to us, 0, minus 2. Used over here, we'll get minus 2 the square by 2 equals to 0 square plus c. Correct? No, x square is 0 square. So we get here 4 by 2 equals to c. C value is 2. Put it back in the equation. We'll have y square by 2 plus x square by 2 plus 2 is the answer. Simplify this. I'll get y square x square plus 4 or y square minus x square equals to 4. That's my result. That's my result. Please check. This is the final answer. This is your final answer. Find the equation of the curve. This is a curve's equation. This is the curve's equation. Please check. Next. This is your LDE. This is your linear differential equation. LDE. So basically, first practice these questions, and if you have time, if you let's say don't have exam tomorrow, you can certainly practice more questions from NCERT. If not all, try to solve solved example after this. Okay. So after doing question practice of this particular session, go ahead and take care of your solved example of NCERT. Please do that, and you'll be good in your PU2 FA2 examination, that FA2 test that you have. Okay. Alright, so if you take the general form, you get this 3 as the px and this as the qx. We have to find our integrating factor. So e power p dx will give me e power, the constant 3 comes out, simply dx is left. So I have e power 3x as my integrating factor. Okay, as my integrating factor, and we all know in this form of LDE, the answer is given by y times of if equals to integration of q if dx. Okay, so y times of e power 3x equals to e power 3x into e power minus 2x dx. Am I right? Yeah. So my answer is y e power 3x equals to integration of e power x, I guess. 3x minus 2x is x, so e power x. We still have dx over here to deal with. Answer will be what? E power x plus c, and y e power 3x. Move this on this side. We'll get y e power x by e power 3x plus c upon e power 3x. So y equals to e power minus 2x plus c into e power minus 3x. That's my answer. This is my final answer. Y as subject, e power minus 2x plus c times of e power minus 3x is the final answer for the given linear differential equation of the form dy by dx plus py qx. Okay, px into y and q of x. Clear. So basically our world revolves around integrating factor. Okay, great. Now the last part of the chapter, last part of your syllabus is going to be 3D geometry. Let's solve the questions over here, and then we can say our preparation for FA2 is complete. Okay, for these 4 chapters: integration, application of integrals, and your differential equations, and the last one is 3D geometry. Do not forget to solve the solved examples of NCERT, of course. So after doing all of this, you can, if you have time, solve this. If you are serious, if you want to actually study for your FA2, after studying all these questions, do not forget to solve the solved example of your NCERT, and your preparation for FA2 will be up to the mark. Getting it? Okay. Alright, now it's time to solve the easiest questions of your entire syllabus, 3D geometry. We'll see how easy they are if you know the formulas. Direction cosine of z-axis is 0, 0, 1 because angle of z-axis with z-axis, listen to me, angle of z-axis with z-axis is what? 0 degree, cos 0 is 1. Angle of z-axis with z-axis is 0 degree, cos 0 is 1. Angle of z-axis with x-axis is what? 90 degree, cos 90 is 0. Angle of z-axis with y-axis is how much? 90 degree, cos 90 is 0. So answer is 0, 0, 1. Answer is 0, 0, 1, option B. Because angles are pi by 4, excuse me, pi by 2 and 0. This is why cosine angles. Cos of pi by 2 is 0, cos of pi by 2 is 0 and cos of 0 is 1. Next, direction cosines of negative z-axis will be simply becoming what? Angle will be pi over there. This is 0 with z-axis. With minus z will be what? Pi. Answer will become minus 1. 0, 0, minus 1. Option B. Okay. If a line has the direction ratio of 2 minus 1 minus 2, its direction cosines are what? Same result. You'll have 2 divided by square, basically sum of all of this. So 4 plus, what is it? 1 plus 4. So 9, root of 9 with plus minus sign. Okay. So we'll get here this as plus minus 2 upon 3. Next will be what? Plus minus 1 upon 3 and plus minus 2 upon 3. So take the combination. The first combination is what here? 2 minus 1 and minus 2. And next is minus 2 plus 1 and plus 2 by 3. So 2 minus 1 and minus 2. Excuse me. And minus 2, 1 and 2. There are two combinations, right? When you take the plus sign over here, this is plus minus, no? When you take the plus sign over here, you get the values of first is positive, second is negative, and third is also negative. So plus minus plus, and the other will be what? Only first negative, rest two as positive when you take the minus sign of the root. When you find the root, you get what sign? Plus and minus, no? That's why. Next, direction cosines of the line passing through the point given like this. So whenever you have 2 points given, you have to find what? First DRs. Let's find DRs first. Check here. So 1 minus of minus 2 is going to be 3 and 2 minus 4 is going to be what? Minus 2, and you'll have 3 plus 5 will be 8. Am I right? 3 plus 5 will be 8. Now squares of all of these to get the magnitude. We'll have here 9 plus 4 plus 64. Am I right? So we get 68 plus 9. 68 plus 9 is 77. Yeah, this will become root 77. So DCs will become basically, the direction cosines will become basically, check here, of course you'll have plus minus signs, okay. So if I just write the values, 3 by root 77, minus 2 by root 77, and 8 by root 77. Option as such. So yeah, option B is the only right choice. Option B is the only one right choice. Clear? All 4 questions are dealt with. Next, 2 problems. If a line makes an angle alpha, beta, gamma with the positive directions of coordinate axis, okay, then what's the value of sine square alpha, sine square beta, and sine square gamma? Okay. So when they say positive axis, they mean that your cosines are cos alpha, cos beta, and cos gamma. These are the value of L, M, and N. Excuse me. Yes, sir. Here. Yeah. So we all know the value property. L square plus M square plus N square is given by 1. Right? In that case, we all know that it will become what? Cos square of alpha plus cos square of beta plus cos square of gamma will be 1. And we have sine square. It means what? I can write this as 1 minus sine square alpha. Right? And 1 minus cos square, 1 minus sine square beta, excuse me, and 1 minus sine square gamma equals to 1. Okay, let's do one thing. Take 1, 1, 1 as sum as 3, take minus sign common. I get sine square alpha plus sine square beta plus sine square gamma equals to 1. And we'll switch the sides. So I have here 3 minus 1 equals to sine square alpha, this sum, okay. Yeah. Sum of sine square alpha. I'll get this value. Okay, this is coming as what? Coming as 3 minus 1, which is 2. So answer is option A. I hope you get it. Summation of sine square alpha means sine square alpha plus sine square beta plus sine square gamma in this case. Okay, same thing. This goes on this side, it will become positive, and this one comes over here, becomes negative. Clear? Next one. Cos to alpha, cos to beta, cos to gamma, we have to find out. Same concept. Formula for this is what? 2 cos square alpha minus 1 plus 2 cos square beta minus 1 plus 2 cos square gamma minus 1. Okay, take 2 common, you'll have here cos square alpha minus plus cos square beta plus cos square gamma, and you'll have minus 3. Minus 1, and minus 1 is minus 3. So 2 times of 1 minus 3, answer is 2 minus 3, so minus 1. So minus 1 means option D. Check here. Option D. Is it clear? Both the questions? Yes? Next question. 2 lines are given, are what? Parallel, perpendicular, they're asking us that. Okay. So as whenever we are looking for Cartesian form of the lines, check the standard form. What is the standard form here, bacha? X minus x1 upon some constant A, y minus y1 upon a constant B, and z minus z1 upon the constant C. Compare this with this. So basically the coefficient of x, y, z should always be 1. Listen to me. The coefficient of x, y, z should always be 1. Here we have 1 and a 1, no problem. Here we have again 1, but we have here minus 1. So we have to transform this equation as this: x minus 2 upon 3, y minus 1 upon 4, and take minus sign common. You'll have here z minus 1 upon 5. So this minus can be written over here. So I can write this as minus 5 in the denominator. Okay. And this is z not 2. 1 second. Yeah. This is z, sir. Okay, so we get z minus 1 by minus 5 now. Now we have the coefficient of x, y, z as always 1. In that case, this is your final equation form then. Once you have that, we are looking for angles. We all know that. That will be simply what? This product of the coefficients here, 3 and 3, 4 and 4, and 5 and minus 5. If it is coming as 0, it means it will be a perpendicular line, or the ratio we have to check then later. Okay, let's try to use the perpendicular first. 3 into 3 is 9, this 3 and this 3 is 9, plus 4 into 4, 16, and minus 5 into plus 5 is minus 25. Check, answer is coming as 0. It means that the value we are getting this one. Please check. A1, A2 sum of A1, A2 is coming as 0. What is this? A1, A2 plus B1, B2 plus C1, C2. This is your A1, A2, B1, B2, C1, C2. So this is the understanding of summation of A1, A2 coming as 0. Hence, the lines are perpendicular in nature. Option B. Okay. Option B. Please check. Good question. Okay. Next one. Find the equation of the line which passes through the point 1, 2, 3. Okay, and parallel to the vector in both vector and Cartesian form. Let's try the Cartesian form first. For question number 5, Cartesian form first. Cartesian form first. So parallel passing through this point, no, means your x1 is 1, y1 is 2, and z1 is 3. And their ABC values are 3, 2, and minus 2. The value of A, B, and C are 3, 2, and minus 2. 3, 2, and minus 2. Please check. So what do we get? X minus x1 means 1. That's the formula we just wrote over here. Please check. X minus x1 upon A. So x minus 1 upon 3, y minus 2 upon 2, and z minus 3 upon minus 2. Z minus 3 upon minus 2. Okay, this is your Cartesian form. What about vector form, sir? That is much simpler. R equals to vector A plus lambda vector B. What is vector A over here? using x, x1, y1, z1. So vector r becomes vector a. So I cap plus 2j cap plus 3k cap and plus sign lambda times of the vector b from here. 3i cap plus 2j cap and minus 2k cap. This is the vector form. This right here is your vector form of the line passing through the point 1, 2, 3 and parallel to the vector 3i cap, 2j cap and minus 2k cap. This represents the parallel form. This is the position vector of the point from where it passes through. Okay, next. Find the angle between the lines this and this. Okay, sir. When we are finding the angle, the first thing remains always same as what? Try to look for the x and y z coefficient as always 1. 1, 1, 1, 1, 1, 1. No problem there. So there is a formula for this one. Cos of theta equals to dot product of the two vectors b1 dot b2 divided by modulus of the vectors mod of b1 and mod of b2. So dot of the vectors and modulus of the vector. Let's find modulus first. That is calculative in nature. Please check. For the first one, 9 plus 25 plus 16. 9 plus 25 plus 16. That is going to be root 50. That's 5 root 2. Please check. 9 plus 25 plus 16. That is going to be again 25 plus 25. So 55 root 2. Let's look for the modulus of vector b2. Yes. So over here we'll have 1 plus 1 plus 4. So that's 6. Correct? No, 1 plus 2 square is 4. That's root 6 only. Okay? Great, sir. Now what do we have now? Have a look. We can use this directly now. Cos theta. So cos theta will be given by product of b1 and b2. 3 into 1 is 3. 5 into 1 is 5. And 4 into 2 is again 8. Divide by root 5 root 2 and root 6. 16 we have over here, and then I get root 5 times of root 12. Okay, so I get 16. 5 into 4 3s are. So I get 5 into 2 into root 3, correct? Root 12 is 4 into 3. 4 root will come out as 2. So that's what we have over here. This will become 8. Now I want to rationalize it. So we'll get root 3 over here and root 3 over there. The answer is what? 8 root 3 upon 5 into root 3 into root 3. So 3. 5 into 3 is 15. This is my cos theta value. So I hope you can see from here cos theta will be cos inverse of 8 root 3 by 15. The angle will be cos inverse of 8 root 3 by 15. I hope this is clear. Please check. Yes. Next. So if you want, I can write it over here. Theta is nothing but cos inverse, right, of 8 root 3 by 15. This is your final answer for this particular question number 6. Okay. Have a look. So I hope you can visualize and understand the variety of questions that I've taken today to make you understand the 4 chapters that we have in our syllabus of FA2. Okay. If I missed something out, don't worry. You can just let me know in the comment section and we'll try to cover up that as well. Okay. Next. Find the shortest distance between the given two lines. First thing is to do what? Find the coefficient of x, y, z to be 1. Okay. Whenever you see Cartesian form, let's look for x, y, z coefficient as always 1, 1, 1, 1, 1, 1, 1. No problem, sir. Now, so we need to find a2 minus a1 first. What is a2 minus a1, sir? a2 represents the position vector of the point it is passing from, the second line, and a1 represents the position vector of the point where the first line passes from. Difference you're going to take, we have what you have 3 minus of minus 1, that becomes 4i cap. How come, sir? Remember, the form is what? X minus a by, x minus x1 by a. So here x1 value is 3. Here it is plus 1. It means it has to be minus 1. X of minus of minus 1. X of minus of minus 1. So when you take the difference of that, you'll get what? 3 minus of minus 1 will become 4. Same way. 5 of minus 1 becomes 6. j cap, and 7 minus of minus 1 becomes 8, right? K cap. Got it? 7 of minus 1 becomes 8 k cap. This is my a2 minus a1. Okay. Now next what we have? Next we have to find out b1 cross b2. Yes, so we need to find what? We need to find the value of b1 cross b2, right? So let's find b1 and b2 first. So we have b1 over here, b2 over there. All right, sir. b1, excuse me, b1 cross b2 will be the determinant value. Let's find that quickly. We have I, j and k. Okay, that's 7 minus 6. 7 minus 6 and 1. 1 minus 2 and 1. So we get minus 6 plus 2, right? That's going to be minus 4. And we'll have with the minus j cap. Check here, this will be 7 minus 1. 7 minus 1 will be what? Just 6, right? 7 into 1 is 7. 1 into 1 is gone. So we'll have 7 minus 1 is 6. And plus k cap. This will be about minus 14 plus 6. That's going to be minus 8, right? Minus 14 plus 6 will be minus 8. I know that you all know how to find the determinant by now. Okay, so my value of b1 cross b2 is coming as minus 4 I cap, minus 6 j cap, and minus 8 k cap, right? Minus 8 k cap. Okay, now the formula for d, we all know that is nothing but, what is this? Dot of these two divided by mod of this. So dot of, if I call this to be, let's say, vector number p, my vector p is this, and this is my vector q actually. I'm giving you a little bit complication, but I hope you can understand that. Not a big deal, just assigning another variable to this. This is, let's say, vector p, and this is vector q, let's say. My answer will be given by, one second, one last removal from here. We have answer as p dot q upon mod of q. Correct, no? Mod of this vector b1 cross b2 and dot of these two. Okay, dot of these two. So you'll get dot product of this as minus, please check, minus 16, and you'll have 36 again negative. You'll have 64 also negative, and this will also be the same thing, 16, and we have 36, and we have 64. So if you check here, this will be, the d value will be what? 116 minus over here and root of 116. D will be 116 by root of 116. So basically 116 in the root. So this is your answer. Of course, you can make a factor of this. You can try. We have 4. You can cancel with 4, right? So if you check, it will become 4 2s are, and we have 4 2s are 8, 3, 4 9 are 36. So we have 29. So 2 root 29, right? 2 root 29, correct, no? Because 4 if you take inside, it will become 13 into 4 is, yeah, correct. This is your answer. 2 root 29, I think. Please cross check. If it is wrong, let me know in the comment section. Yes. Do let me know in the comment section. Okay. Now let's conclude the session with the help of this derivation. I think this is it. Yeah. This is going to be the last question of the day. We're going to derive the equation of the line in a space passing through a point in both vector and Cartesian form. Let's draw the figure first. Okay, I can draw bigger. I will need that. Okay. And let's say there's a point with the coordinate A is given as x1, y1 and z1, and the line is passing through the point A like this. This is a I have taken a point P on this arbitrary point xyz. Okay, this vector O, the origin to this point is this one. OA vector is given as vector A. This line AP is parallel to a vector B. This is parallel to a vector B. Okay, and I'm looking for the general form of this particular vector. This particular vector right here. Please check. Okay, this will be given by my vector R. In the vector form, we'll see the Cartesian form later. Okay, so if I'm looking for a vector form, we all know that we'll write the vector AP. Since vector AP is parallel to vector B, so I can write the vector AP as lambda times of vector B. Any problem with that? Since AP since AP and B are parallel, it means I can write vector AP as lambda times of vector B. Any problem? No. Now in triangle OAP, if you apply triangle law of addition, that we have learned in our vectors, okay, we can write OA plus AP as vector OP. What is OA? OA is the vector A. It represents the position vector of the point A. A represents the position vector of the point A. What is AP? Lambda B. And what is OP? R. So basically I have got the value of R as A plus lambda B. If you remember, this is your vector form. This is your vector form of what? Of a line passing through a point A with the coordinates x1, y1, z1 and parallel to the line B, which is basically, let's say I can write this as AI cap, BJ cap and CK cap. AI cap, BJ cap and CK cap. Okay, this is a vector form. What about Cartesian form, sir? Same thing. If you have R like this, no, what is it? R equals to we have A lambda B. Can we write R? Can we write R in the Cartesian form? Yes, sir. We have the points x, y, z. For the point P, we have the form, right? So we can write the vector for that. We'll get what? R as xi cap, y j cap and z k cap. This is the vector R over here. And what is the vector A? We just wrote here x1 I cap, y1 j cap and z1 k cap. Please check here. x1, y1, z1, so vector will become x1 I cap, y1 j cap and z1 k cap. I hope you all know to find it. This point's coordinate is what? 0, 0, 0. So vector will be x1 minus 0, y1 minus 0 and z1 minus 0. That's how you find the position vector, right? x1 minus 0, y1 minus 0, z1 minus 0. For this point, x minus 0, y minus 0 and z minus 0. That's why we got the vector R as this and vector A as that. No problem? No. And vector B is already given to us, lambda times of AI cap, BJ cap and CK cap. You can cross check over here. Vector B is known to us. Okay. Now with all this information that we have used, I can simply find the values directly over here. Please check. I'll move this on this side. So I'll get x minus of x1 with I cap, and I get here y minus of y1 with j cap and with j cap, excuse me, last one, and we'll get the last one as, what is it, z minus of z1 with k cap, and this is equals to what? What is it? A lambda I cap plus B lambda j cap plus C lambda k cap. Now if you compare the components of I cap and I cap on both sides, okay, so basically this and this on both sides, you'll have something. Please check. X minus x1 equals to A lambda. From here I get x minus x1 upon A as lambda. What I'm doing, comparing the x, y and z components. Okay, now do for y component. I'll have y minus y1 equals to B lambda, so I get y minus y1 upon B as lambda. Okay, same fashion, I'll get z minus z1 equals to C lambda, so I get z minus z1 upon C as lambda. Since lambda is a parameter, a constant value, and they are coming equal to lambda, all of these, it means I can make the Cartesian form directly over here now. X minus x1 by A, y minus, excuse me, y1, right, by B, and z minus z1 by C. This is your Cartesian form. This right here is your Cartesian form. I hope this makes sense to all of you, both vector as well as Cartesian form derivative of a line which is passing through a point which is given and parallel to a line which is also given. Here is the figure, vector form and Cartesian form. This completes our preparation, our revision for FA2 PU2. Do not forget to solve some more questions after doing this. Just solved examples. okay, from NCERT of these chapters if you are scoring for 35 to 40 marks. If you are scoring for 35 to 40 marks, try this as well. You have time, you can do that, and why not get out of marks in this examination, in this FA2. It will give confidence going in our preps, preparatory, in our pre-boards. We have to this year, so we have to be on our toes with our preparation, and every bit helps, right? So if I missed something, let me know in the comment section, but I have delivered what you asked for in this session. The complete revision of the 4 chapters, including 1 marker, 2 marker, 5 marker, 6 marker, all of that can be asked from these chapters. The chapters names I'll repeat again: integrals, application of integrals, differential equation, and 3D geometry. Okay, so with this I can end the session today. Thanks for listening to me in this particular class, and we'll meet again very soon. Till then, take care. Bye bye.